In this video, we will be using pH buffer 4 and pH buffer 7, but what exactly is a buffer and why do we use them for the pH meter?
A buffer is essentially a neutral solution that will resist pH changes when an acid or base is added.
They're able to resist these changes because they are either made of a weak acid and its conjugate base or a weak base and its conjugate acid.
We use buffers to calibrate the pH meter because due to their pH stability, we can accurately measure the pH of other solutions, such as the unknown solution in this video.
First, obtain a pH meter. 2 beakers, one filled with distilled water for storage and the other for cleaning waste. pH buffer 4 and 7 distilled water bottle and chem wipes. We will use the 2-point method for the most accurate calibration. This will consist of pH 7 buffer, and for this particular lab, we will use an acidic solution, hence the pH buffer 4.
You'll remove the electrode from a storage solution with care. Make sure to not spill the storage solution and not bump the electrode while handling it. You will rinse the electrode with DI water and place in the pH 7 buffer. You'll hit calibrate, 2-point method, and enter 7.00 for the first pH.
You will remove the electrode, rinse with distilled water, wipe it with a chem wipe, and then place it in a pH 4 buffer. You'll enter 4.00 for the second buffer solution. Afterwards, you will rinse it with DI water and store it in the beaker of distilled water.
You can verify if the pH meter was calibrated correctly by placing the electrode in one of the buffers and see if it reads the known pH correctly.
Once the pH meter has been calibrated, you're ready to find the pH of a solution. After rinsing the electrode with DI water and wiping it, place it in the solution and wait for the pH reading to stabilize. Record the pH before removing the electrode.
After you're done with the pH meter, rinse it with DI water and wipe it once more before placing it back into its stored solution. For this lab, the solutions can go down the sink and all glassware must be washed and placed back in their proper storage.
With all this talk of pH of buffers and unknown, what's the difference between a weak and strong acid and how does it relate to equilibrium?
The acids differ in their proton dissociation behavior. A strong acid will completely dissociate in water. For example, HCl is a strong acid, and look how it dissociates into ions completely.
Meanwhile, a weak acid will only partially dissociate in water. For example, acetic acid is a weak acid, and notice how it barely dissociates and relatively remains intact.
There will be no equilibrium when a strong acid is dissolved in water because it will fully dissociate, thus the reaction is complete. Meanwhile, a weak acid will eventually reach equilibrium because there are still molecules and ions present, where it can become reversible.